Hi everyone, I am Yunyon. Today I am going to present you how to create an animation of a cardioid. A cardioid is a plane curve traced by a point on the perimeter of a circle that is rolling around a fixed circle of the same radius. Now I am going to make two identical circles which are tangent externally. To do so, I am going to mark the center point of the fixed circle at the intersection of the two axes using the point 2. To make a circle, I use the circle 2, namely circle with center through point, and click on the point A and then click on the axes. In order for a circle to roll on the circle C, we have to mark a pre-point on the circle C. This is a pre-point. Notice that the point A is black. It is fixed, not free. And the point C is free and point B is free. Point B is free to move on the axes, and point C is free to move around the circle. Now I am going to make another circle that is tangent externally to the circle C. To do so, I use the point command. Using the point vector, the point must be the initial point A, and the vector must be twice the vector A, C. Then the point D appear. Here you can see that the distance AC is equal to the distance CD, and at D I am going to make a circle with center D and radius CD. So I use circle with center and radius command and click D and give the radius CD and click OK. Then I get another circle which is identical with the original circle and which can move around freely on the circle C. Initially, the two centers A and D lie on the axes. When the circle D starts to roll around the circle C, the point C moves away from the point B and produces a central angle BAC to the circle C. Likewise, it must produce the same, the identical central angle to circle D. So I first measure the angle, central angle BAC, and I get the measure to be alpha. So the central angle to the circle D must also have the measure alpha. So I make the central angle with the measure alpha to the circle D. I give the measure to be alpha. Then the central angle beta, which is equal to alpha, appear on the circle D. Actually, C prime is the original tangent point of the circle D. To see this, I try to move C back to the point B. As you see, the 3 points coincide, and as the circle D starts to roll around the circle C, the tangent point C prime also move away from the point B, and as the point C approach to the point B, so does the point C prime. Now we are ready to construct the parametric representation of the point C prime. In fact, C prime can be represented by a vector from the point A to the point C prime. Now you can see that the vector u is equal to the sum of the vector from the point A to the point D, and the vector from the point D and to the point C prime. Unfortunately, we cannot use the vector W because its initial point is not the same as the other two vectors. Every vectors in the representation must have the same initial point, and it must be the origin. So we have to copy the vector W to the point A. To do so, I use vector from point command, and I click on the point A and on the vector W. Then I get a copy of the vector W to be a vector A. Then we can say that vector U is the sum of the vectors A and V. Now, in order to generate a curve, in order to generate a parametric curve, I use the curve command here. And this command, like this. This expression, the first expression is for the x coordinate of the point C, and the second expression is for the y coordinate, and the third is parameter variable. It must be we shall use t for this end. This is start value of the parameter, and it must be 0 degree, and the end value of the parameter, it must be alpha in this case. Then what is the x coordinate of vector C prime. It is clearly seen that the x coordinate of vector, the point C prime is that of D, the point D, and that of the point A. Then x coordinate of the point D is length AD, which is the magnitude of vector V times cosine alpha, and x coordinate of point A prime is length A to A prime, that is the magnitude of vector A times cosine alpha plus 1, that is cosine pi plus 2 alpha. So we can type now magnitude of vector V times cosine alpha. But in the parametric representation, we mustn't use the accurate value because alpha is here for the end value of the parameter. So in the parametric curve, in the parametric representation, we must only use the parameter. So for alpha, in place of alpha, we use t plus a magnitude of vector A times cosine pi plus 2t. For the y coordinate of C prime, we copy the x coordinate expression and replace cos by sine. Replace cos by sine. The parameter must be d, and the step value must be 0 degree, and the end value must be alpha. Okay, now we get we get the parametric curve for the point C prime, which starts from B, and to get a complete curve, we copy the parametric curve and what's wrong? Control A, copy, and replace alpha by 2 pi. Then we get a complete curve. And now we modify the color of the curve, and the segment of the color to be brown, and the color of the complete curve, to be red, and the thickness must be very small, and the segment of the curve must be brown and with thickness, with a thick. Okay, to see how the point C prime move. We shall move C on the circle. This is the parametric representation of the cardioid. In order to create an animation, I shall introduce a Boolean variable, OK, and give it initial value true, that is equal to 1, and I create a button. Click here and its initial caption to be OK, and then I shall modify the object properties. In the on-click box, I shall type 5 statements. The first one is to start the animation of the point C, this point. And the second line is to change the caption of the button OK to stop. And if I click on a button second time, the Boolean value every time I click on the OK button, the Boolean value will change according to the fit line. If the value of OK is 1, true, then it will change 0, false. And if its value is 0, and it will change the fit line, the statement will change the value of OK to 1. According to the logical value, the statement 1 through 4 will work. If the value of OK is 1, that is true, then it will start the animation, and it will change the caption of the button 1, OK button, from OK to stop. If the value of OK is 0, that is false, then it will stop the animation, because of the Boolean value of the start animation command is pause, and will change the caption from stop to OK again. Okay, let's see the animation. Now you can see the animation. And if we want to stop the animation, we just click on stop button, and if we click again, the animation will start. Thank you for watching my video.